Solving and graphing inequalities using interval notation. So inequality notation is just when you are rewriting expressions using inequality symbols, which we have less than, greater than, less than or equal to, or greater than or equal to. We've also in Math 1 and 2 talked about interval notation, rewriting inequalities using numbers, infinity symbols such as plus or minus infinity, and or both with grouping symbols such as brackets or parentheses. So brackets represent, remember, closed dots on our number line, and these are going to be underlined inequalities such as less than or equal to, greater than or equal to, or equal to. Parentheses always represent open dots and are not underlined inequalities such as less than, greater than, or not equal to. An open dot, or sometimes we say open circles, when the point is not a solution. A closed dot is when the point is a solution, such as these two examples here. If you have more than one interval, then you can go ahead and use the union symbol. So for this first example, go ahead and pause the video and do the examples A through F on your own, and then when you're finished, unpause to check your answers. Looking at A, we have the inequality notation, x is greater than -2. So on my number line, I'm going to go to -2, and I'm going to make an open circle because it's not equal to. And then when I shade my number line, I want to shade values that are greater than -2. So that's what my graph would look like on a number line. And if I want to write the interval notation, you always start with the lower number and go to the greater number. So the lowest number on my number line is -2, and it's not equal to, so we use parentheses -2, and we go to infinity. And infinity is not a number, it goes on forever, so we don't include the value, so that's why we use a parentheses and we don't ever use a bracket. Looking at the next one, we have x is less than or equal to 1. So at 1, we are going to have a closed circle. And then we are going to shade our number line values lower than 1 or less than 1, which goes this way. And so for this, we have then to write our interval notation. So notice this goes down to -infinity. So we have to start with a parentheses. So parentheses -infinity to 1, and that's including 1. So we use a bracket. Looking at the next one, we have values of x in between -3 and 0, including both those values. So on our number line at -3, we have a closed circle, and at 0, we have a closed circle. And on our number line, we are going to shade in between. And so if we want to write our interval notation, because we're including both values, we have bracket -3, comma, 0, bracket. For the next one, we have all real numbers. So all real numbers means that we are shading the entire number line. And so when you shade the entire number line, that means that all real numbers is -infinity to infinity. And so parentheses, -infinity, comma, infinity, parentheses. For the next one, we have all real numbers x not equal to 2. So all real numbers not equal to 2 means that at 2 we're going to have an open circle, and everything else would be shaded on my number line. So going that way and going this way. And then for the interval notation, parentheses -infinity, comma, 2, parentheses, union, parentheses 2 to infinity, parentheses. For the next one, we have x is less than -1. So at -1, we have an open circle, and we are going to shade values that are less than that, so that goes to the left. And then we have or x is greater than or equal to 2, so here's 2, and then we shade to the right because we want numbers greater than that. And for this, we have then parentheses -infinity to -1, parentheses, union, bracket, 2 to infinity. Now be very careful when you are writing your parentheses and your brackets. Make sure your parentheses look like parentheses and brackets look like brackets, because usually if I can't tell in a test or quiz, I do mark them wrong. You could always write next to them if it is hard to tell. So as with inequations, the solutions to an inequality are numbers that make it true. The properties for solving inequalities are similar to the properties for solving equations, which you all know how to do. The exception occurs when you multiply or divide each side by a negative quantity. So, and we've talked about that last year, so we'll do some example problems. When you're solving inequalities, you must follow the three rules. So rule one, if you multiply or divide both sides by a negative number, then you flip the inequality symbol. Rule two, to help write your solution set, always place the variable on the left side. You don't have to, but again, it just kind of is helpful to have the same answers. Rule three, you must write your solution set or final answer in interval notation. So for examples, it says solve each inequality equation and write your answer using interval notation, then graph. So looking at the first one, the first thing we want to do is, if this was an equal sign instead of an inequality symbol, we would solve it by first getting rid of the -6 first, because remember, you do the order of operations backwards. So that's PEMDAS backwards. So we want to get rid of things added or subtracted to the variable, which is this 6. So to get rid of it on the other side, we have to add it. Then next is multiplication and division. So what do we have being multiplied by the variable? The 3. So we're going to divide both sides of the inequality symbol by 3, which gives us x is less than 11. And so the x is on the left side. We didn't multiply or divide both sides by a negative number, so we don't have to flip. And then all we need to do is go ahead and use our number line to help us figure out the solution. So on your number line, you don't need to write all the values. You just really need the x is less than 11 and put some numbers on either side. So if this is 11, this would be 12, 13, 14, 15. 11, 10, 9, 8, 7, 6, 5. So we'll just put those numbers there so we know that these are the lower values and these are the higher values. And we have an open circle here at 11, and we want values that are less than 11, which goes this way. So for this, the interval notation would be negative infinity to 11, and we use parentheses. So this is the solved inequality equation, and then we write our answer using interval notation, and we also graphed it. Looking at the next one, if I'm going to solve this equation here, the first thing it would do is distribute that 3 to both these terms right here. So negative 2x is less than 3x minus 15. Then the next step would be to get your variables together on one side. So here I want to get these values together, and it doesn't matter which side you choose, but it would be easier to take the 3x to this side. So minus 3x. So this would give us negative 5x is less than negative 15. We're trying to solve for x, so we need to get rid of that negative 5, which means we're dividing both sides of the inequality by a negative number. So divide by negative 5. Remember, when you do that, you have to flip the inequality symbol. So in this case, this symbol is going to go the other way. So this means we have x is greater than, and negative 15 divided by negative 5 is 3. So on my number line, I have 3. This would be 5. This would be 1. And at 3, we have an open circle, and we have x values greater than 3. So that means we're going to shade to the right. And my interval notation would be parentheses 3, comma 5, or 5, 3 to infinity, parentheses. And then we are done. So let's go ahead and look at the next one. So over here, we do the same thing. I'm going to distribute first. So 2x is less than 2x plus 2 plus 3. Combine your like terms. So 2x is less than 2x plus 5. And then here, we want to get our x's together on both sides. So I'm going to subtract the 2x. So we get 0 is less than 5. Well, notice that our variable's gone. So since our variable's gone, keep in mind this is not an equal sign. This is an inequality symbol. So ask yourself, is 0 less than 5? Yes, that's a true statement. Because it's a true statement, that means that anything we plug in for x will always be true. So that means we would actually shade the entire number line. So this whole number line would be shaded, which means our answer would be negative infinity to infinity. Over here for the next one, we're going to distribute. And then we want to get our x's and our numbers together on one side of the inequality equation. So I'm going to go ahead and subtract the 4x. And I get negative 12 is less than, or excuse me, greater than or equal to 1. And depending on how you solve this, you might have ended up with something slightly different. And so you're just looking, does it make a true statement or a false statement, because we don't have any x's here in our final statement. So is negative 12 bigger than or equal to 1? No, it is not. So this is a false. So this means there are no solutions. That means when we solve this equation here, no matter what we plug in for x, this right side will never be greater than the left side, and that is why there are no solutions and nothing is graphed on the number line. All right, the next part is compound inequalities. A compound inequality is two inequalities joined by an and or an or, and is solved by solving each part of the inequality. So an or compound inequality is the union of the two inequalities. So that means union, you're using both solutions. And the and is the intersection. So this would be an example of an and. Another way that you can write this would be written as negative 8 is less than x, oops, no, sorry, not negative 8, negative 9 is less than x, which is less than 6. So that would be another way to write this as an inequality. And if we want to write this using our interval notation, this would be parentheses negative 9, comma 6 parentheses. And up here, if we were to write this, this would be negative infinity to 3 bracket union bracket 4 to infinity. Now we're going to solve each compound inequality equation and write our answer using interval notation in the graph. So you guys can go ahead and pause the video and do the first one on your own, and then we'll check it together. So for this first one, I'm going to get my x's together. So I'm going to subtract the x. So 2x minus x is just x, and then we have 6 on the side, so x is greater than 6. And over here, add the 7. So x is less than 9. So since this is an and problem, that means we're going to shade the intersection. So if on my number line, I need a 6 and a 9. So here's 6, 7, 8, 9. And we know that we have numbers that are greater than 6, not equal to. So numbers greater than 6 go this way. Here we have numbers that are less than 9 but not equal to, so open circle going this way. You're looking for where the two are going to overlap. So if you look here, they overlap in between these values here. So on our number line, this would be an open circle, and we'd shade this and here. And so if we want to write this using our interval notation, we would write parentheses 6 comma 9 parentheses. All right, so let's go ahead and look at the next one. First thing I would do is go ahead and distribute. And then we're going to get our x's and our numbers together. So I'm going to go ahead and subtract 2x to the other side. And then we want to get our numbers together, so I'm going to add the 6. So this gives us 5 is less than or equal to x. And we need to solve the next one. So I'm going to subtract the 4x to get the x's together. So I get negative 3x is greater than negative 9. Then I divide both sides by negative 3. And notice that I'm dividing both sides of the inequality by a negative number, which means I need to flip the inequality sign. So this becomes x is less than, and negative 9 divided by negative 3 is positive 3. So for this, on my number on 9, I have x is less than 3. So here's 3. It's an open circle. Numbers less than go this way. Here I have x is greater than or equal to 5. So here's 3, 4, 5. We have a closed circle. And our numbers are going to be shaded going this way. And this is an and problem, so you look for the two overlap. Well, what happens when none of them overlap? Then that means there are no solutions, because it doesn't work for both of them. Why don't you guys see if you can go ahead and do this next one on your own, and then when you're done, unpause the video. So for this, we're going to add the 1. X is less than 4, and this is an OR problem. Here we're going to subtract the 3. So x is greater than 5. And on my number line, I have the 4 and the 5. We have numbers that are less than 4 and numbers that are greater than 5. So because this is an OR problem, we want x values that work in either of the two equations. So that means that anything that we have, we can bring down to our number line and shade. So everything works except for the numbers in between 4 and 5. So negative infinity to 4, parenthesis, union, parenthesis, 5 to infinity. All right, so for the next one, go ahead and solve. So the first thing we want to do is subtract the 9. And then the next thing we're doing is divide by 3. And again, you're dividing negative 12 by 3, but you didn't divide both sides of the inequality by a negative value, so you do not flip the inequality sign here, so don't get that mistake. Some students usually do that. So this is still x is less than negative 4, or, and over here add the 1. Divide by negative 2. Now we're dividing both sides of the inequality by a negative number. So now we go ahead and flip the inequality symbol. So we have x is less than negative 4 or x is greater than negative 3. So here's negative 4 and here's negative 3. 0 would be here. So we have values of x less than negative 4 and greater than negative 3. So that's what we would shade on our number line. Because this is an OR problem, we shade everywhere we have a line. So negative infinity to negative 4, union negative 3 to infinity is our interval notation. And looking at E, this problem, if you ever see something with two inequality symbols and then you have variable in between or on either side, this means this is an AND problem. So if it helps you to write them separately, you can. So notice we have this equation right here. So 8 is less than m plus 6. And we also have this equation right here. So I'm going to write and m plus 6 is less than 14. So you can then go ahead and solve the equation, or you can solve it all together. It's up to you how you want to do that. So minus the 6. So 2 is less than m. And subtract the 6 here. M is less than 8. So on my number line, we have 2 and 8. So at 2, we have an open circle, and it says that m is greater than 2. And over here we have 8, which is an open circle, and values less than 8. This is an AND problem, so we want to shade where the two overlap, which is from here to here and in between. So all these values. So the interval notation would be parenthesis 2 to 8 parenthesis. A strip of wood is to be 17 centimeters long with a tolerance of plus or minus 0.15 centimeters. How much should be trimmed from a strip 18 centimeters long to allow it to meet these specifications. So they like these questions on standardized tests. So think about it this way. We have an 18 piece of wood and we're cutting stuff from it. So we have 18 centimeters and we're cutting X amount. So of course X stands for the amount that you're trimming from the wood. And it says we want it to be 17 centimeters long with a tolerance of plus or minus 0.15. So that means that has to be in between and equal to these values. So 17 plus the tolerance and 17 minus the tolerance. So then the next step would be to go ahead and solve this equation. So 17 minus 0.15 is 16.85 is less than or equal to 18 minus whatever we cut, which is less than or equal to, and if you add these together, you get 17.15. And so now we can go ahead and solve this inequality equation. So you can solve this separately by making two equations. So 16.85 is less than or equal to 18 minus x. And then the second equation would be this one right here. So, and 18 minus x is less than or equal to 17.15. So next step is to solve for the variable. So PEMDAS backwards, subtract the 18. So when we do that, we get negative 1.15 is less than or equal to negative x. And over here, subtract the 18. So negative x is less than negative 0.85 or 0.85. And then the next step is to divide both sides by negative 1. Notice that we're dividing each side of the inequality by negative values. So that means we need to flip these inequality symbols. So this gives us 1.15 is greater than or equal to x. And here we get x is greater than 0.85. So if we write this together, or if you look at a number line, 0.85 would be here. We have values that are bigger than that. 1.15 would be here. We have values that are less than that. So where did the two overlap? They overlap from here to here, and this should be equal. Sorry about that. That's a closed circle. I don't know why I left it out with the equals. There we go. So that means we need to be in between these two values. So 0.85, if you want to write, is less than or equal to x, which is less than or equal to 1.15. And if we wanted to write the interval notation for this, this would be bracket 0.85 comma 1.15 bracket. So that means no more than 1.15 centimeters and at least 0.85 centimeters of the wood should be trimmed. And then if that's the case, we will have met our specifications for the problem. And that's it.